Okay, so DVDs hold approximately 7 times more capacity than a CD, which is why most people have switched to DVDs. Switching to DVD addresses the capacity problem, as DVDs offer approximately 7 times more capacity than a CD, but it does not address the more fundamental issue of using physical media to transfer images. Having to share a physical disk among health care providers has many important challenges. First, although it may be feasible in smaller facilities to simply pass the disk from one healthcare provider to the next, or to have the patient carry it, this does not work well in more complex clinical scenarios. Patients with complex or intricate problems typically see multiple providers, creating contention for access to the single imaging disc that might be important in decision-making. Additionally, in the film era, it was not uncommon for a film to be lost. This scenario is totally possible for a disc, and losing all the patient's examinations would have an even greater impact. Handling the disc also risks physical damage that may make the disc unreadable. For these reasons, sharing the disc among healthcare providers is not an optimal solution, which is why usually what happens is they bring the CD or DVD in, and it goes right to the PACS team to be imported. So once it's in your PACS, you don't have all of those sharing problems that I talked about on the slide. However, you still have the physical damage problems. Many times I've gotten a DVD that was scratched or dropped or backed over in the parking lot, and then the disc is totally unreadable, and you just have to tell the patient to go get another one. Importing an IHE. An alternative to sharing the physical CD or DVD is to import the CD contents into the local image viewing system, most commonly the PACS. Until recently, most PACS did not have efficient tools to import CDs, and I would say they still don't. Now this option is more widely available and is often implemented in a way described by IHE. The IHE provides 2 main variants of image import reconciliation, where one is scheduled and one is unscheduled. The main difference is that in a scheduled workflow, the system creates an order before the import is performed, which potentially allows information, such as the type of examination, to be included in the text description presented by the image viewing system. In the unscheduled scenario, the images are imported, but no additional information about the study is provided. In which case, you just got to go to the RIS and create an order, and then match it up, right? Every image needs to have an order to match it up. And in the scheduled scenario of IRWF, the order comes in as soon as you start the import process. In the unscheduled one, you have to manually go and make the order. So either way, you're still going to need an order. It's just how you do the import. So who is the right patient? Another important challenge that's not widely recognized is the low data integrity of CDs. There are physical and logistical components to data integrity. When the physical integrity of the disk is degraded, scratching or bending the disk, it can become unreadable. A more insidious integrity issue is whether the data on the disk truly belong to the intended patient. In one recent report, it was found that 1% of disks contained information that was derived from multiple patients, and another 1% contained only studies from a single patient source that was different from the intended patient. In many such cases, the other individual had a nearly identical name or medical record number. The mistake was likely due to operator error during CD creation. In other words, just because somebody hands you a disk doesn't mean that it's their images on that CD. It's very possible when you get a disc from John Smith that whoever made the disc picked the wrong John Smith. It happens, unfortunately, about 1% of the time. And how much does that CD really cost? Finally, there is a substantial cost of transferring images by physical media. The media itself is cheap, typically a fraction of a dollar per disc, nickel, dime. However, the cost to produce a CD is rather high, and though it's hard to determine the true costs. A survey of several institutions suggested the labor and system cost is in the range of $15 to $25 per disc. The cost is higher when images must be produced in an ad hoc fashion, requiring a query for a specific examination from the image archive and having a person wait while the images are written to the disc, and then creating a mailer and mailing the disc. The charge to the patient for creating a CD varies from nothing for the first copy to more than $40 per disc, right? So when you're trying to figure out how much does a CD really cost, you've got to consider not just the cost of the disc, but the cost of the labor. How, who's making this disc? Is it being made by a file clerk, or is it PACS admin, or is it CT tech making this disc? What is their cost per hour? How much does it cost to have the patient wait, then give it to them? So that means the tech has to stop scanning and work on that disc, or the PACS admin has to stop working on the system and go make that disc. And of course, if you're mailing it, then you've got mailers and postal charges. So CDs aren't as cheap as people think they are. Image sharing on the cloud. The benefits of cloud-based imaging sharing platforms are becoming clearer to stakeholders across the entire healthcare enterprise. There is new value creation from cloud-based imaging by making the images easily accessible for radiologists, referring physicians, and most importantly, the patients. Cloud-based image sharing ensures increased availability of imaging studies in space and time, geographically and among multiple healthcare providers at the point of care. The key benefits include increased quality of care, reduced cost, reduced hassle of duplicative imaging examinations, and potentially decreased duplicative radiation exposure. Instead of sharing images through physical media such as a hard copy and a CD, cloud-based image sharing enables files to be digitally transmitted in minutes or less. Furthermore, elimination of physical media saves costs and reduces potential errors for lost or corrupt data. The speed of image sharing will reduce the chance that the patient care is affected by delayed diagnosis or treatment. Opportunities to reduce radiation dose occurs when cloud-based image sharing tools can avoid unnecessarily repeat nuclear medicine, X-ray, or CT imaging, particularly for patients who may be transferred between institutions or who receive care at multiple facilities. Cloud-based image sharing represents a major evolutionary step in healthcare informatics, enabling sending, sharing, and access to imaging from multiple disparate facilities. Security is also a factor when evaluating systems designed to transfer digital data, particularly healthcare data. A critical question to ask of any vendors: where are the images physically hosted? A high-security, HIPAA-compliant data hosting center is essential. Data centers used by vendors need to meet strict standards for data protection in order to be HIPAA certified. These standards include specific on-site training for personnel. Data centers must also be subject to government audits by HIPAA inspectors. When selecting a vendor, one should inquire about prior audits and HIPAA certification of data centers used to store medical imaging data. So, let me pause here and talk for a minute about Hawaii. Hawaii is obviously has 5 major islands, if you didn't know that, and it's very difficult for people to get from one island to the other, so it's hard for them to carry their images on a CD around with them. So in Hawaii, we used a system called Beam. It's a cloud-based sharing. All the hospitals subscribe to the Beam service. So if a patient is on the Big Island and they need to go 300 miles west by plane to get to Honolulu to have a particular type of surgery done, because they don't do it on the Big Island. Option A, somebody's got to burn their studies on a CD, put it with the patient. It's got to go with the patient on the plane. If the CD doesn't make it, when they get to their destination in Honolulu, they're going to repeat the studies. It's faster, safer, more secure, and easier to just take that study, upload it on the application called Beam. It goes up into a cloud server that meets these security requirements, and then the team in Honolulu can pull it down, and it's right there, and they've got it ready to go. So when it works like it's supposed to, it's way better, faster, and safer than using CDs. A solution is both secure and HIPAA compliant must have the following features: identification and authentication, authorized privileges, access control, confidentiality, integrity of data, accountability, and audit trails. So think about that in that Beam application, right? You have to give your identity to the Beam application. You have to be authenticated through a login. You have to have the right privileges. There has to be access control, so you can't do more than you're supposed to. It has to keep everything confidential. The data has to have high integrity, so nobody can get into it, and only people that should get into it can get into it. And of course, it has to have accountability and audit trails to know who's been looking at the images in that application. And don't forget the network. Cloud-based services require significant investment in network resources and internet bandwidth. In the non-cloud healthcare enterprise, users are accustomed to advantages of a high-speed local area network. In a non-LAN environment, namely a cloud-based environment, users may experience performance or latency issues resulting in potential customer satisfaction issues. If the data centers are located geographically across multiple sites, or if there are internet-related outages, the network speed and ultimately access to mission-critical medical imaging data may be affected. As a result, in order to limit exposure to the risk of bandwidth compromises, testing of cloud-based vendors and cloud-based solutions are requisite. The cloud infrastructure must be stress tested to ensure the healthcare data stored in the cloud is accessible, minimizing bandwidth bottlenecks. If there are any bandwidth issues during the testing phase, it is recommended the healthcare facility work with the vendor to resolve any potential issues prior to deployment of a cloud-based image sharing solution. Let me make that real world. The clinic on Kauai wants our images. I load them from Honolulu. I'm loading them on a fantastic, gigabit connection. They go right to the Beam servers. But the connection from Kauai is on a modem. It's on a phone modem, right? They don't have high-speed internet to the Kauai clinic. So, their transfer time from Beam down to them is forever. If they want, a CT study, they got to start downloading it 30 minutes before they're going to need it. So, just because your network is great and the Beam servers are fantastic, that rural clinic out in the woods, it may not have the best internet, and that's going to cause some user frustration at that end. Key features necessary for a cloud-based image sharing solution. For the image storage, you got to have security, HIPAA compliance, and a backup. You don't want them losing your data. You don't want people who are not HIPAA approved to look at your stuff. For image data integration, distribution, and sharing, they must be compatible with everybody's packs, not just your packs. It's got to be compatible with everybody's packs. It has to have an ease of integration into healthcare enterprises, and it must have DICOM routing. The image viewing must have a viewer. It doesn't have a zero footprint viewer available. And, what does it cost? You need to know if it has a fixed or subscription pricing. Is it elastic or pay-as-you-go plans based on data or bandwidth usage? So there's a lot of different cloud-based image sharing solutions out there for radiology, and you want to look at all these features when you're deciding whether or not to use one. Thank you for watching.